we would be discussing in detail. So this is carbonyl compounds. This is carbonyl compounds. Carbonyl compounds, right? So those compounds in which you will see functional group, that is carbonyl. So the functional group is so the functional group is C double bond O. Okay, this is the functional group that we would see in carbonyl compounds. C double bond O. Okay, so this functional group you will see in two compounds. This functional group you will see in two compounds. Number one is aldehyde and number two is ketone. Number one is aldehyde and number two is ketone. So this is aldehyde, and then we have ketone. Aldehyde and ketone. तो इन दोनों में जो है ना कार्बोनिल कंपाउंड प्रेजेंट होता है. So what's the identification? What's the identification for these two compounds? So you will see K aldehyde is this R C double bond O, then H. This is aldehyde, and ketone is RC double bond O and R. This is ketone. So that's the difference between aldehyde and ketone. Okay, you can see on the left hand side you have R and this is H, and in ketone both of the sides having R groups. And I told you that what is R group? R group is in any carbonyl group. R is any alkyl group. उसमें कार्बन हो सकते हैं. It may be you can say methyl, बोले तो CH3, या तो वो it may be ethyl, that would be C2H5, or it would be propyl and etc. Propyl क्या होगा? C3H7. Okay, so this is your alkyl group. तो वो कुछ भी हो सकता है. So the general formula for aldehyde and ketone I told you. Okay, so if I talk about the simplest aldehyde, so this is simplest aldehyde is ethanol. And you know ethanol is this CH3 C double bond O then H. This is ethanol, the simplest aldehyde. इससे कम वाला possible है ही नहीं. Okay, इससे कम वाला possible नहीं है. Or you can say the simplest ketone, that would be propanone. That is CH3 C double bond O and then CH3. This is your propanone. और इसको आप ये भी कह सकते हो कि this is like you can say prop 2 on. इसको आप और भी कह सकते हो क्या? prop propane 2 on, because we have to describe the position of the carbonyl group. But in aldehyde, you are not supposed to describe the position of this C double bond OH, because this is understood that it would be present ऑन द एक्सट्रीम कॉर्नर्स। तो मतलब कि उसमें तो आपको जरूरत ही नहीं है बताने की कि व्हाट्स द पोजीशन ऑफ दिस एल्डिहाइड, सेकंड पर है, थर्ड पर है, फोर्थ पर है, फिफ्थ पर है, सिक्स्थ पर है। सो इट्स नॉट नेसेसरी, इट्स नॉट मैंडेटरी। ओके, तो दिस इज प्रोपेन टू ऑन, दिस इज प्रोपेन टू ऑन एंड you can see कि let's suppose I'm going to make the quite large structure so that I can say कि ये जो आपका एल्डिहाइड है इसमें जो R ग्रुप है, इसमें जो R ग्रुप है दैट इज योर इलेक्ट्रॉन डोनेटिंग ग्रुप। ये हमने पहले भी बात की हुई है कि दिस इज इलेक्ट्रॉन डोनेटिंग ग्रुप। R group is electron donating group. So R is going to donate its electron and R is going to donate electron from both sides. R is going to donate electrons from both sides. You know what does it mean? कि अगर ये दोनों तरफ से इलेक्ट्रॉन जो है वो डोनेट कर रहा होगा, so what would happen basically? What would happen? So due to the presence of this highly electronegative element that is oxygen, due to the presence of highly electronegative elements that is your oxygen, so it would be partial negative, है ना? ऐसे ही होगा ना? It would be partial negative and the carbon would be partial positive. कार्बन पार्शियल पॉजिटिव हो जाएगा और एल्डिहाइड आपका यानी कि जो ऑक्सीजन है इट वुड बी पार्शियल नेगेटिव। सो आई कैन से कि दिस इज पार्शियल नेगेटिव and this is partial positive, which makes it polar, which makes it polar. So I can say that due to electronegativity difference, due to electronegativity difference, electronegativity difference, this carbonyl group is polar in nature. It's polar basically, it's polar. Acha, polar means ke like what is the type of intermolecular force of attraction? Okay, what type of intermolecular force of attraction in this? So you will say permanent dipole. You will say it's permanent dipole. Okay, I told you that permanent dipole is there between the polar molecules and London force, or you can say induced dipole, or you can say आपका जो temporary dipole है, it's present between the non-polar ones. It's present between the non-polar ones. So this is permanent dipole. This is permanent dipole. Okay, so I can say this is the polar one. I can say this is the polar one, right? Okay. Acha ji. So we can also write this as R C H O. Okay. तो OH और OH और HO में थोड़ी सी confusion है. So alcohol is OH. This is not OH. This is HO. So you will get to know कि हाँ यार this is your aldehyde. So you have to take care it कि यहाँ बच्चा थोड़ा सा mix कर देता है. So HO is aldehyde, OH is alcohol, okay? And this can be represented by RCOR. RCOR, okay? Um, so uh, since you know that this carbon is partial positive, so who can attack on this? Who can attack on this? So you will say nucleophile. So you will say nucleophile. तो nucleophile basically क्या कर सकता है? Can easily attack on the carbonyl group because the carbon is positive and nucleophile is going to have a negative charge. So obviously बात है, this would give us a reaction that is called nucleophilic addition reaction. Okay, nucleophilic addition reaction. Okay, so I can write case since It's going to have partial negative and partial positive charge, polar nature. Nucleophile can attack easily. It generally gives nucleophilic addition reaction. It generally gives nucleophilic addition reaction. Okay, nucleophilic addition reaction. So let's talk about the physical properties of aldehyde and ketone. Physical properties. Carbonyl compounds. ओके जी, तो सबसे पहले हम डिस्कस करते हैं इसका बॉइलिंग पॉइंट और यू कैन से मेल्टिंग पॉइंट. क्या कहते हो? What should be the boiling point of this? So the simplest aldehyde is your gas. Okay, तो बाकी as the number of carbon increases, as the number of carbon increases, so the intermolecular forces of attraction is going to get stronger. So ultimately, we can say that its melting and boiling point would be increasing. Melting and boiling point would be increasing basically. Okay. तो जो लेस नंबर ऑफ कार्बन्स वाले आपके पास हैं, जो लेस नंबर ऑफ कार्बन्स वाले आपके पास हैं, सो उनका दे आर gases, they are liquids, and as the number of carbon increases, so their melting and boiling points are going to be increased. So let's do comparison between the melting and boiling points of alkane and then aldehyde and then alcohol. Um first of all, I can write that less, yani I can say carbonyl compounds having less number of atoms are gases at room temperature. क्यों? 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 क्योंकि अल्टीमेटली उनमें इंटरमोलिकुलर फोर्स ऑफ अट्रैक्शन ही इतनी कम होगी. बात समझ रहे हो? तो एज द नंबर ऑफ कार्बन इंक्रीजेस, सो फिर वो गैस से क्या हो जाएगा? gas to liquid, and फिर और increases, so you can say कि it's going to be it's going to be solid. तो फिर it depends on the number of carbon atoms. So number of carbons, number of carbons are directly proportional to the strength of IMF, strength of IMF, and ultimately you can say it's going from gas to solid. सही है जी. ओके, तो इंटरमोलिक्यूलर का फोर्स का रेफरेंस यू मस्ट मेंशन, यू मस्ट मेंशन. ओके, so this is your alkane first. Let's see, this is your alkane, this is your alcohol, and this is your aldehyde. अब देखिएगा जरा इनके बॉइलिंग पॉइंट्स को. Or for to be specific, this is my ethane. CH3, CH2, CH3. This is this is minus 42 degrees Celsius. It's the boiling point. And if I talk about the ethanol, is simplest है बिल्कुल. So you will see कि it's plus 21 degrees Celsius. सेट हो गया. It's the boiling point. Or this is, मैं अल्कोहल को नीचे कर देता हूँ. This is your alcohol. इसका देख रहे हैं आप लोग. बॉइलिंग पॉइंट सेट हो गया. चलें जी. तो नाउ यू कैन हैव अ कंपैरिजन के अल्कोहल का बॉइलिंग पॉइंट सबसे ज्यादा होता है. क्यों? व्हाई? सो लेट मी टेल यू दैट के your alkane has only your alkane has only London force. Your alkane has only London forces. London forces बोले तो है भाई a temporary dipole. London force means temporary dipole, or I can say dispersion force, which is the weaker force as compared to your aldehyde is going to have permanent as well, and temporary as well. दोनों होते हैं इसके पास, दोनों होते हैं इसके पास. ओके. अब नाउ यू आर थिंकिंग दैट हाउ इज दैट पॉसिबल कि दोनों ही इसके पास हैं. यू कैन सी ओवर देयर के we have like let's suppose I'm talking about the five membered let's suppose four membered aldehyde. So this is your polar side. It would be having permanent dipole. And what about this? The rest of the things, it's non-polar. So they would be having like the temporary dipole, like which is called ID force, induced dipole, which is the weakest intermolecular force of attraction. So as the number of carbon you can see over there, तो उस carbon में you will see कि there should be like simple force, that is your London force, or I can say ID force, that is the temporary force, or and also the permanent dipole. Why? Because you have a functional group that is C double bond OH. Obviously, due to the difference in electronegativity, oxygen is having partial negative charge and carbon is having partial positive charge. So, इसमें दोनों forces होती हैं. जबकि you will see in alcohols, hydrogen bonding भी होती है. Hydrogen bonding plus temporary भी होती है. So you know that okay, if we are going to like compare these three intermolecular forces, so we will see that okay, alcohol is the stronger one. We will see that alcohol is the stronger one. Alcohol is the stronger one. क्यों? कि तीनों में जो सबसे ज्यादा strong force of attraction होती है, तीनों में जो सबसे ज्यादा अट्रैक्शन स्ट्रांग है, दैट इज कॉल्ड हाइड्रोजन बॉन्डिंग. सो दैट्स व्हाई आई एम सेइंग कि अल्कोहल इज हैविंग हाई बॉइलिंग पॉइंट एज कंपेयर टू दीज थ्री. तो दिस इज द कंपैरिजन. ओके. और आई कैन से दैट के जबकि एल्डिहाइड में ऐसा नहीं हो रहा है. ओके. एल्डिहाइड में ऐसा नहीं हो रहा है. सो यू हैव टू सी when you are going to do a comparison between the two molecules, okay, what type of intermolecular forces of attractions they have basically. Okay. And solubility in water. Solubility in water. Like uh, the next property is solubility. Solubility. What do you think? Are they soluble in water or insoluble in water? Yes? Hmm? Any idea? हाँ भाई, क्या कहते हो? कोई ऐसी बात जो आप लोग सोच रहे हो कि हाँ यार, इसे soluble होना चाहिए, इसे insoluble होना चाहिए? Yes? Hmm? Any idea? Hmm? जल्दी बोलो. No idea. दुआ, ईमान, हादिया, हफ्सा, सईद मोहम्मद अहमद, सिमोना, उमना, जैना, सुमर, क्या कहती हो? What about the solubility? Are they soluble or insoluble in water? Yes. हाँ जी. Can you hear me? Can you all hear me?
Yes, sir.
तो क्या कहती हो बेटा? Are they soluble or insoluble in water? Hmm?
Soluble
Soluble. क्यों क्यों क्यों?
because of
क्यों soluble?
polar side, the carbon and
हाँ,
oxygen.
हाँ, yes, 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 Hafsa, yes. So they are polar. They are polar. Okay. So and they do form hydrogen bond with water. They do form hydrogen bond with water. They are soluble, but unfortunately, when you are going to increase the number of carbon atoms, okay, when you are going to increase the number of carbon atoms, so the hydrocarbon part is the non-polar part, so the water is polar. So its solubility would be decreasing. Its solubility would be decreasing as the number of carbon increasing. So that's the main point, okay? So they are polar, since they are polar in nature, so they should be soluble in water. और दूसरी बात ये कि form hydrogen bond. They form hydrogen bond with water. कैसे? You can see this. How they are going to form hydrogen bond with water? Since you know that this is partial negative, this is partial positive. Okay, this is the water molecule. And this is the charge. तो ये जो है ना ये, this is your hydrogen bonding. This is hydrogen bonding. लेकिन मसला ये है कि this is your ethanol versus both are aldehydes, both are aldehydes. लेकिन दोनों में फर्क क्या है कि you can see कि this is the hydrocarbon part, this is the hydrocarbon part, which is non-polar, which is non-polar. तो इसलिए जैसे जैसे नॉन पोलर पार्ट इंक्रीज होता जाएगा तो इट वुड बिकमिंग अ डोमिनेंट फैक्टर, it would becoming a dominant factor. तो ड्यू टू दिस फैक्टर इसकी जो solubility है वो क्या हो जाएगी, decrease हो जाएगी. Okay, so that's why I told you कि as the number of carbon increases, so the solubility is going to decrease. Okay, so this is your polar part. तो ये आपका लेस soluble है, ये more soluble है. वो लेस soluble है, this is more soluble. क्यों? कि इसमें नॉन पोलर का जो पार्ट है इट्स वीकर, इट्स लोअर. So we want polar ones to make it soluble in water. Okay. तो ये है तो पोलर, बट ऑब्वियसली बात है कि जब ये चेन की लेंथ वुड बी इंक्रीजिंग, सो इट वुड बिकमिंग अ डोमिनेंट फैक्टर. दिस इज वन एंड ओनली रीजन कि ऑब्वियसली दे आर, सो द लेस नंबर ऑफ कार्बन वाले जो कार्बोनाइल हैं दे आर soluble, but जो higher number of carbons वाले compound हैं, like it may be aldehyde, it may be ketone, तो they would be insoluble in water. Okay, and you can say कि then which one is more polar, aldehyde or ketone? This is the main question because we are going to move to the chemical properties of aldehyde and ketone. Chemical properties of aldehyde and ketone. So remember कि ये जो मैंने charges लिखे थे ना, तो like this is positive, this is partial negative, तो वहां पर भी मैंने आपके सामने लिखे हुए हैं. Okay, so which one is having a strong पार्शियल पॉजिटिव कार्बन, ये वाला या फिर ये वाला? एल्डिहाइड का कार्बन इज स्ट्रॉन्ग पार्शियल पॉजिटिव, या फिर कीटोन का कार्बन जो है लाइक कार्बोनाइल कार्बन is more partial positive. Like I'm going to talk about the stronger charges and how will we get to know okay the charge is stronger or the charge is weaker, right? Okay, so you can see over there okay, this positive charge is going to be balanced by the two R groups. This positive charge is going to be balanced by the two R groups because the nature of R group is an electron donating group. So when it's going to donate electron to this partial positive carbon, तो फिर क्या होगा? Okay, यहाँ से भी और यहाँ से भी दोनों जगहों से ultimately they are going to balance this positive charge. So you know what would happen? It would become less stronger partial positive charge, less partial positive. Okay, it's not quite stronger. क्योंकि it's going to be balanced by electrons which are coming from these two R groups. It's going to be balanced. It's going to be balanced. This effect is known as inductive effect. This effect is known as inductive effect. Okay, तो ये आपने याद रखना है. अच्छा जी, चलें जी, अब हम आ जाते हैं इनकी preparations पर. Preparation of carbonyl compounds. So the first one is, so the first one is alcohol to alcohol to aldehyde. So how can I convert from alcohol to aldehyde? How can we do this? Alcohol to aldehyde. So it depends के कौन सा alcohol you have. You have primary alcohol, you have secondary alcohol, or you have a tertiary alcohol. So if you're going to take 1 degree alcohol, so you are going to add any oxidizing agent. In this case, K2Cr2O72 minus slash H plus heat under reflux or heat and distilled. अगर तुमने इसको heat under reflux किया तो it would not be producing your aldehyde बल्कि वो क्या बन जाएगा carboxylic acid. I don't want to produce carboxylic acid, so you have to provide like the certain condition. So you will see that your aldehyde would be produced after the oxidation of primary alcohol. After the oxidation of primary alcohol, you will get aldehyde. You will get aldehyde. So this is an oxidizing agent, that is K2Cr2O7. Okay, K2Cr2O7, orange to green, or this H plus is going to represent acid. एसिड क्यों डालते हैं पता है? It's used as a catalyst. It's used as a catalyst in an oxidation process. तो in short मैं आपको ये बताऊं कि we can prepare aldehyde, but the thing is that examiner would be giving you the initial product, like the starting reactant, I can say. तो नाउ स्टार्टिंग रिएक्टेंट इज अल्कोहल, तो अल्टीमेटली आप खुद ही सोचोगे ना कि यार इट शुड नॉट बी एन एल्डिहाइड, क्यों? कि सॉरी, इट शुड नॉट बी सेकेंडरी अल्कोहल, क्यों? सेकेंडरी अल्कोहल आफ्टर ऑक्सीडेशन इट गिव्स अस यू कैन से कीटोन. तो पहले हम एल्डिहाइड को देख रहे हैं, देन वी विल सी ketones. Okay, so one by one I would be going ahead. तो let's suppose, to be specific, alcohol is this. CH3OH. I'm going to do oxidation. I'm going to do oxidation. तो you know कि क्या बन गया, ये देखो, aldehyde is produced. Aldehyde is produced. Aldehyde is produced. Okay, this is the sample for oxidizing agent. This is the sample for oxidizing agent. If you're going to provide certain conditions like that, K2Cr2O72 minus, which is an oxidizing agent in the presence of acid catalyst, and we are going to do heat and distilled. Once your aldehyde is formed, so just do separate your aldehyde and go for further reaction. Okay, so you can also convert this aldehyde into the carboxylic acid if needed. If needed. So frequently you will see this symbol, this sign. You know what does it mean? This means that uh, oxidizing agent is going to produce this oxygen which is very reactive, which is very reactive. So ये क्या करेगा, इस प्राइमरी अल्कोहल को क्या बना देगा, एल्डिहाइड बना देगा. ओके, so that's very easy. तो ये आपका है 1 डिग्री अल्कोहल, and what is this? This is aldehyde. This is aldehyde. Okay, so this is the first preparation of aldehyde from alcohol. So the alcohol should be primary alcohol, not any other alcohol. So what would you observe? What would you observe? So I'm going to write observation. I'm going to write observation. So observation में orange to green. Orange to green. This is your observation. Okay. चलें जी. अब हम आते हैं अब हम आते हैं अल्कोहल टू कीटोन. अल्कोहल टू कीटोन. टू बी स्पेसिफिक मैं इसको ना इस तरह लिख देता हूँ, अल्कोहल टू कार्बोनाइल, ताकि मैं आई हैव अ like full space के I can prepare aldehyde, I can prepare ketone. So alcohol to carbonyl. अल्कोहल टू कार्बोनिल। तो सबसे पहले मैंने क्या बनाया, एल्डिहाइड, एंड नाउ आई एम गोइंग टू प्रिपेयर अ कीटोन। ओके, so this is your 2 degree alcohol, 2 degree alcohol. Say we would be preparing ketone. Okay, ketone. So the same oxidizing agent can be used. You can use K2Cr2O7 and you may use KMNO4. Both are the same. Both are the same. Okay. तो ये लो, ये मैंने ले लिया सेकेंडरी अल्कोहल. ओके, दैट इज दिस. और ये बन जाएगा आपके पास. सही है जी. ओके, तो Cr2O7. व्हाट शुड आई से, हीट अंडर रिफ्लक्स, है ना. हीट अंडर रिफ्लक्स, हीट अंडर रिफ्लक्स, तो आपका कीटोन बन गया ये. तो इस तरह से यू कैन प्रिपेयर मल्टीपल प्रोडक्ट्स, यू कैन प्रिपेयर मल्टीपल प्रोडक्ट्स. ओके, and further oxidation of aldehyde is going to give you further oxidation of aldehyde is going to give you carboxylic acid. मैं वही मेंशन कर देता हूं कि further oxidation further oxidation further oxidation would give you carboxylic acid, जो कि ये है CH3C double bond OH. This is your carboxylic acid. Same reagents और conditions use कर रहे हैं हम. Okay, तो इसलिए if you don't want to produce this carboxylic acid, once the product is formed, so you are supposed to distill off the product. Okay, so aldehyde can be oxidized further, but if you have produced ketone, तो ketone cannot be oxidized further. That's the main point जो कि आपको पता होना चाहिए. Okay, so this product this product cannot be oxidized further. It cannot be oxidized further. सही है जी. ओके, अच्छा, you know why it cannot be oxidized? Oxidation means addition of oxygen or removal of hydrogen. Okay, oxidation means addition of oxygen or removal of hydrogen. There is no hydrogen to remove. There is no hydrogen to remove. So ultimately, I can say that it cannot be oxidized further. So if you have primary alcohol, so you can produce two products, aldehyde or carboxylic acid. और अगर आपके पास 2 degree alcohol है, that is your secondary alcohol. So secondary alcohol would be oxidized into ketone, and आप ketone को further oxidize जो है वो नहीं कर सकते हो. Okay. So now I want to do a reverse reaction. I want to do a reverse reaction. कैसे? कैसे? You can see this K. What I told you K. Uh, I have primary. I have primary alcohol. इससे आपने क्या बनाया? एल्डिहाइड. इससे आपने क्या बनाया? एल्डिहाइड. And then in the end, what did you produce? Car Carboxylic acid. Okay, क्या यूज किया आपने? Oxidizing agent, that is acidified potassium dichromate, and heat or distilled heat or distilled. And for aldehyde to carboxylic acid, you have used the same thing. Okay, heat under reflux. Heat under reflux. But I want to go backward. You know, I want to go backward. तो वो मैं आपको बता दूं कि उसके लिए what you are supposed to do, I want to go backward. तो ये देखिएगा जरा, यानी मैं अब यूं जाना चाह रहा हूं. ओके, I want to go backward in this way. In this way, I want to go backward. यानी कि प्रोडक्ट में सेम बना रहा हूं. This is my primary alcohol. Okay, or this is aldehyde again, or this is carboxylic acid again. This is carboxylic acid again. मतलब कि कुछ इस तरह से सेट हो गई बात. तो कि this would be called reduction. Reduction. तो अगर आप carboxylic acid को you are going to reduce it, you would be getting aldehyde. And if you are going to reduce aldehyde to primary alcohol, so you can use any of the reducing agent. You can use any of the reducing agent. Remember, any of the reducing agents. It's reduction. It's reduction. तो इसके लिए what's the condition? इसके लिए what's the chemical that we are supposed to use to reduce this carboxylic acid into aldehyde and then aldehyde into alcohol? Okay, so it's LiAlH4. It's LiAlH4 in dry ether. ये इसका solvent है. ये इसका solvent है. LiAlH4 in dry ether. In dry ether. It's reduction. It's reduction. So if you are going from left to right, it's oxidation. And if you are going from right to left, if you are going from right to left, so it's reduction. It's what? It's reduction basically. So it's a reducing agent, LiAlH4 in dry ether. And there is one more reducing agent, that is NaBH4. जैसे आपको दो ऑक्सीडाइजिंग एजेंट याद है ना, एक KMnO4 and another one is K2Cr2O7. So same goes with the reduction. We have two reducing agents. Okay, the first one is LiLH4 and the next one is NaBH4, that is called sodium borohydride. Okay, so LiLH4, by the way, it's a strong reducing agent. Okay, so I'm going to mention it. Okay, we have two reducing agents. We have two reducing. We have two reducing agents. कौन कौन से हैं? Let me tell you this. The first one is LiAlH4 in dry ether. Okay, which is a stronger, which is a stronger reducing agent, or I can use NaBH4, which is weaker comparatively. ओके हो गया जी, सेट हो गया. तो ये आपको लाजमी पता होना चाहिए. ओके, चले जी, चले 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 चले. ओके 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 ओके. So I'm going to write equation. Okay, so the first one is aldehyde को if you want to convert into primary alcohol, and इसको further आप नहीं सही है, ओके। तो एल्डिहाइड इज दिस, सिंपल ले रहा हूँ बिल्कुल, 2 कार्बन वाला। यू विल बी प्रोड्यूसिंग दिस प्रोडक्ट। क्या यूज किया आपने, पता है ना? LiAlH4 in dry ether. So if you will be producing LiAlH4 in dry ether, so you will be getting primary alcohol. You will be getting primary alcohol. सही है जी, okay. This is your first reaction. This is your first reaction. Let's do another reaction. Okay, let's do another reaction. Another reduction, I can say. So the second one is from ketone to secondary alcohol. Second reaction क्या है? Ketone to secondary alcohol. That is 2 degree alcohol. Okay. So ketone, I took the simple one ketone, that is propanol. That is propanol. So propanol को जब आप reduce करोगे through LiAlH4 in dry ether, तो आपको क्या मिलेगा? तो ketone को when you will be reducing, so you will be getting secondary alcohol. What's the formula? What's the structure for secondary alcohol? तो वो होगा कुछ ऐसा। दिस इज योर सेकेंडरी अल्कोहल। सही है जी। तो मतलब बताने का ये है कि we can oxidize and we can reduce. It's up to you, okay, what you want to do. So we have both options. Okay, we can convert alcohol into aldehyde. We can reverse back from aldehyde to alcohol again. So we have an option. Okay, चलें जी। अच्छा, सब में आई एम गोइंग टू हीट, सब में आई एम गोइंग टू हीट, राइट? सब में आई एम गोइंग टू हीट, सब में वी आर हीटिंग, विदाउट हीटिंग द रिएक्शन इज नॉट पॉसिबल, विदाउट हीटिंग द रिएक्शन इज नॉट पॉसिबल। तो मैं सब में मेंशन कर रहा हूं ताकि आपको याद रहे कि दिस इज हीट अंडर रिफ्लक्स, दिस इज ऑल्सो हीट अंडर रिफ्लक्स बेसिकली। सही है? ओके, चलें जी। देन carboxylic acid, then carboxylic acid से किस में? एल्डिहाइड में। और एल्डिहाइड से अल्कोहल तो मैंने आपको बता दिया। अच्छा जी, ओके हो गया जी। तो दिस इज योर कार्बोक्सिलिक एसिड, और ये आपको एल्डिहाइड मिल गया आफ्टर रिडक्शन। सेम हम बार बार यही करते रहेंगे, हम बार बार यही करते रहेंगे, हीट अंडर रिफ्लक्स। सही है जी, ओके। तो इट्स वेरी इजी कॉन्सेप्ट के हम इसमें मल्टीपल रिडक्शंस जो है वो करवा सकते हैं। सो दैट्स द रिएक्शन ऑफ यू कैन से एल्डिहाइड एंड कीटोन। ओके, so let's see कि when we would be doing the past papers, what the examiner is going to ask. कि sometime he would be giving you aldehyde, sometime he would be giving you ketone. But the thing is that you need to identify कि what he has given to us, what he has given to us. So you need to mention first. जब आपको पता ही नहीं है तो how can you do the reaction? How can you do the reaction? That's the main point. Okay. So inshallah we would continue this chapter, okay, in next class.